trace or copy the graph of the given function f and assume that the axes have equal scales, and then sketch the graph of the derivative function below it. So first thing is that the derivative is estimated by drawing a tangent line at the point x, f of x, and approximating its slope. So the first thing you want to do is you want to be able to then look for horizontal tangent lines, and these are where the x-intercepts of the derivative function will be. So here we can see that there's one horizontal tangent line, and that represents that the slope is equal to 0. And so that's going to tell us where the x-intercept is on the derivative function. So let's go ahead and do that. I'm going to go ahead and there is our slope, and therefore the x-intercept is going to be located at 0. So therefore there is our x-intercept. Okay, now the next thing is that we want to do is we need to determine, okay, are there any discontinuities? So that means we're going to look for a corner or sharp points or vertical tangents in our graph. Well, this graph doesn't have any, so we can skip step number 2. Now for step number 3, the derivative function will be positive where tangent lines of the function have positive slopes, excuse me, and negative where the tangent lines have negative slopes. Okay, so you can see here that over here it's starting out positive, so therefore we can see that these slopes are positive. So it's going to be starting above the x-axis. Okay, and so it's going to increase, so the slopes here, we can see here that each slope is going to increase, and then eventually it's going to then decrease. So then our slopes will then decrease until it gets to the x-intercept. So the way our graph would look like on this interval from here to here would be the following. Again, we're starting with slopes that are above the x-axis, and then it's going to then increase and then it's then going to go back down through the x-intercept. So that's the first half of this graph. Okay, now we want to take a look at what's happening on this interval on this side. Okay, so what's happening here, we can see that these slopes, once it's turning, is still decreasing, and then eventually it's going to start increasing. And you can see that it's going to level out to where it represents 0. So again, our slopes are decreasing to 0, and then it's going to continue to decrease, and then it's going to increase again. So it's going to go through 0 here, it decreases, and then it's going to increase again. And then it's not going to go past the x-axis, and therefore that's going to represent the derivative function of this function.